Good afternoon, everybody. It's a pleasure to be here. I want to first thank all of our hosts. Thanks to all of you for attending, and thanks to all the moderators and panelists today. This has been an incredible event. So I did what you're not supposed to do for presentations, is I have too much information and too many slides to possibly share in my time window. So I'm going to whiz through this, so please keep your eye on the screen. This is where I'm from in Kremling. You can see zoned in on the bottom left, and then a little tighter and a little tighter. And I think that for my story of agriculture and some of the work that we're doing right now, you really have to understand a little bit about where we've been to understand where and why we're going there. So this is a nice area looking upstream of the Colorado River at the confluence of the Blue River right at, and Muddy Creek, I should say, right from the town of Kremling. So a couple decades ago, when we experienced heavy drought in what I would say the 02-03 timeframe, for the first time historically in that portion of the Colorado River, we saw really a struggling river system. So that's a diversion structure for a fixed pump intake that was clearly not operational. These are what the fixed pump intakes look like. For them to operate at 80% efficiency, they've got to be covered by a minimum of 18 inches of water. And this was the life that we started to see we were going into. Really cranky neighbor, demanded a fix sooner rather than later. The engineers and I went to the liquor store, grabbed a 30-pack of Bud, went back to the shop, and by the end of the night, this is what we had. Engineered riffle. I took a copy of it that night based on the fact that there were some beers involved just to make sure we wouldn't lose it. And long story short, here is now an engineered riffle ensuring that those pump intakes are covered at 18 inches of water at a minimum low flow in a river system. I want to minimize the river presentation, but to say that that partnership has been going on for well over a decade in the valley around the Kremling area. We have installed over $4.5 million of work, both on farm and in the river. It's been a truly amazing partnership to be a part of, and really what built and led to this. So when the demand management conversation was going on, our roundtable was working on some stuff. The state came up with their work groups. Some of us were asked to participate in the ag work group. The long story in the end was that there was a heavy understanding that there were some scientists that were concerned we were missing some information to be having the dialogue. So it was not a demand management project. We did not try to deliver the water anywhere. It's a scientific research project, and to understand what it takes to put a collaboration like this together, here's your list of partners. So it was actually a Colorado Basin Roundtable project, primarily funded by the Water Conservation Board. But it took this many people to work on this project for the last 3 years, and it continues to be ongoing. So while you read the research questions, so I'm not reading, I'll give a little bit further background to this. It was a concern of Dr. Perry Cabot that enough information regarding how we analyze consumptive use at high altitude perennials that we weren't there. And given the potential of remote sensing, he wanted a scaled project to look at how we could analyze that differently using different tools of research. And so we ended up having 9 different project participants. We had just under 1,000 acres fully curtailed in the year 2020, and then just under 200 acres that were a deficit irrigation where the producer was cut off of their irrigation water by June 15th. So with this, we've got the fancy eddy covariance, and then we're testing this on some remote sensing applications. I will tell you that my wife despised this project because it took a lot of my time. Until in the remote sensing conversation, she realized I was actually in meetings with people from NASA, and she was actually quite impressed that we were doing this kind of work. That's not exactly my background. But so here's a graphic of pixels and what it looks like when you're looking at this with remote sensing. So pretty fascinating. When you're looking at the red and the ramp, it can be a minimum of 3.93 inches of ET. When you're looking at the green, it can be up to 39.4. So in the bottom left of the diagram is the year 2020, where we dried up those 2 main hay fields, and in the center that wasn't supposed to be dried was the reference field. So most of these fields that were dried in 2020 had a companion reference field to go back to and to look at. And these slides, please forgive me, I would like to be quick to honor our guests. There is a report out, and all this information is available, and if you're really into this kind of stuff, there is an abundant amount of it there. I'd like to just point out on this one that on the historical comparison, so you can see the line 2020, so the top part is the full season irrigation curtailment, and then the bottom is the split season. And you can start to see some of those numbers about where water savings came from. And it's really interesting in 2021 in both circumstances for the full curtailment and not the split season, the water was down from what its historical function was. It's interesting because 2021 was a brutal water year and water supplies were tight. It was another dry year, but it also is a question to how the response of some of the forages came back. This slide, treatment versus reference, also fascinating. When you look at the 2020, you can see the treatment and reference on the left there, the 10.71 versus the 25.67. These are all incredibly interesting. I'm very excited that we originally slated this project to be multiple years because, as stated, 2020 and 2021 were pretty tough water years for all of us. 2022 was slightly better, not great. And this year we're looking to have a really good water year. So I look forward to continued analysis of this data, and anybody, regarding jumping to conclusions, I think that this project is worth the time to wait to understand in a longer time frame. The forage recovery from an ag perspective, which is really one of the reasons that I personally was willing to get involved in this, is if the scientists need the data and the understanding, that's great, but if my neighbors or myself are going to participate, what is it going to mean to us? And I think that my general takeaway from it was, what we would think from our gardens or scientific books or our hay meadows that we know are the best, is some places really suffered from this, other meadows not so much. Some meadows bounce back really quick. The total yield differences are pretty fascinating. The yields, each producer was asked to pick a low production area and a high production area, and the low production areas suffered much more coming back to responding to going back to an irrigated condition than the high production areas did. The crude protein, though, is like a totally different story, and looking at some of the bounce back of protein, it's just also fascinating. And I'll be quick with this because as we're going through next steps, there's a pile of these as this project will continue, and I think there'll be a lot more than just the one more year of study. We're already in conversations about leaving the eddy covariance tower in place for a longer period of time to continue data analysis. But beyond these next steps, what this has grown to, because of some of the things that we've learned, is we knew in the locations where our soil was the healthiest and we had the right forages, in theory, they should perform better. Well, we were pretty astonished at some of the things we saw with total consumptive use of water and total volume of production. And so now it's a little bit more of a challenge about how can we convert some of the fields that were on the other side of the story, higher water use, lower yield, to be in the more productive zone. And so we started working with, I started in conversation with the Land Institute dating back to, I guess, 3 or 4 years ago. This was a field tour at the ranch this summer discussing some of these things for how to do it. And there was another grant awarded this March by the Water Conservation Board, a number of partners that are in this room, where we have some theories about sandfoin and very excited to test and further test some of those theories and how we would be able to grow it. This is Kernza. I would focus less on Kernza as intermediate wheatgrass because in our application at Grand County, we are not grain producers. We are forage feed growers. We are feeding livestock. We're cow-calf operators. And so we're very interested to see how this performs as a forage feed for livestock. We planted some up to 8,000 feet last year to see its longer-term performance. Ongoing projects will be planting more. And then this is Silphium. And what all of these plants, the thought process is that they all have the ability to save water. But when we talk about saving water, another near and dear conversation to my heart is we often get tracked into policy, big river issues, potential water conservation programs, SCPP, demand management, name them all. I have 2 very good friends in Grand County that their families have historically been on their properties. Physically and legally, number one in the watersheds that they live in, never historically had they been short on water supply to irrigate until 2020 and 2021. So for me, the concept of looking at some of these plants that could both withstand greater scarcity to water based on natural supply, or perhaps have the opportunity to participate in conservation programs while still growing food, because I think as the conversations bounce around about this, what is important to me, regardless of what is necessary for potential water conservation programs, is that we are thinking about our soils, we're thinking about our food production, we're thinking about what it means for the long run, because I would definitely like for my children to still eat food grown in the Colorado River. So with that, thank you very much and have a great afternoon.